Okay, we've looked at naming different types of alkanes, including branched alkanes. This video focuses on naming of other organic molecules. The ones included in this video are alkanes, alkenes, haloalkanes, alcohols, aldehydes, ketones, and carboxylic acids. So there's a general set of rules that we follow, and so step one is always finding the longest chain of carbons, which we call the root. Then step two is the numbering the carbon chain, starting with the side with the important group on it, so the one that makes it one of these types of molecules. So for alcohols, the group is OH. For aldehydes, the group is a carbon double bonded to an oxygen and to a hydrogen there. For a ketone is similar to an aldehyde, where you've got carbons and you've got a double bond oxygen there. And carboxylic acid is where you have a double bond OH like this. So they're the important groups that you will see. Obviously, haloalkane is like a chlorine, or it could be a bromine, or it could be an iodine, or it could even be a fluorine. So it's one of those. And lastly, an alkene is carbon double bonded to another carbon. So once you've worked out what the functional group is, you number from that side. Then you include the correct suffix. Now a suffix is the end of a name, so that's this part here. And then you put the right prefix on as well. So the prefix would be any kind of substituent group, which we've covered in a previous video on alkanes. So let's have a look at putting this into practice. So here's the alcohol group. So we can see various different alcohols here. So the first thing we'll do with this one, we'll look at the longest carbon chain. Now this is only a single carbon, so it's a methyl. Now the functional group's over here, and this is an alcohol, so it ends with ol. And there's only one carbon it can be on, so we don't really need to number the carbons in this case. So this is just called, there's no substituent group, so there's nothing that needs to go as a prefix. The next one, once again, we've got an ol at the end there. The longest carbon chain is 2, so that means it's an ethanol. And we need to decide to number it, so 1 and 2. However, if you were to flip this around on this position, if you were to reflect it, 1 and 2 are interchangeable. So this side, it would just make that 1 and that 2, so you don't need a number for that. So ethanol, there's no substituent group on any of these, they're just hydrogens, so we don't need any kind of prefix. With the next one, this is a 3 carbon chain, so it's propanol. And I'm going to leave a gap here because there are 2 positions that the alcohol could live on. Now, because the alcohol's over here, the alcohol group, I'm going to put the numbers starting 1 over there. And we can see it's on the first carbon rather than being on the second carbon. So there's 2 options here. It could have been on carbon 2 or it could have been on carbon 1. If it was on carbon 3, that would just count as being on carbon 1 because it's on the end again. So this is propan 1-ol. And that shows you where the alcohol group is attached. Now there's no substituent groups on here, so we don't need a prefix, so we just leave it like that. The next one is again a 3 carbon chain. This time the alcohol group's on the second carbon. So if we number here 1, 2, 3. So this is actually propan 2-ol. So you can contrast. Next one we're going to look at is alkenes. So alkenes have a double bond. Now we're going to do a whole separate topic on alkenes, but this is just how we name them. So the double bond means that they're unsaturated carbons, hydrocarbons, and it means we can add stuff to them really easily. That's why they call them unsaturated. Now, if we name them, we need to take into account the ene, so we call it what we would call an alkane, but with ene instead. So this is a 2 carbon, so it would normally be ethane, but we're going to call it ethene. Now, there's only one place the double bond can be, so we don't need a number there. With this one, it's 3 carbons, so it's propene. And we don't need a number because if we swapped the position for the double bond to there, it would still be between the first and the second carbon. Okay, this way we'd number it 1, 2, 3, but we just have to renumber it anyway if we move the bond there, so it would be 1, 2, 3. So it doesn't matter. We can sort of flip this molecule around and it's symmetrical. So it's just propene. You don't need a number for that one. With this next one, you will need a number because there could be a double bond where it is here, or it could be a double bond in there between the two middle carbons. So it's really important that this is numbered. Now, we have to number from the side where the important group is, so we start on this side. It's got 4 carbon atoms long, so it's butene. And this is a but1-ene because the double bond is between 1 and 2 there. Okay, there's no substituent group, so we leave it like that. There's also an unsaturated hydrocarbon called an alkyne, and that's where we have a triple bond between the carbon atoms. These are a bit more unusual, and you simply name it with "-ine" at the end. So this one here has 2 carbons long, so the IUPAC name for this is ethyne. We don't need a number because there's only one place that this triple bond can be. With this one here though, this is a 4 carbon chain, so it's butyne. And this is going to have to be but1-ine because if we number the carbons from the important side, we can see that the triple bond is between the first and the second, so we put it with 1-ine rather than being between the second and the third, in which case we'd call it 2-ine. So that's but1-ine. Then we've got carboxylic acids. So for this one, we've got 2 carbons. So 2 carbons. There's a symmetrical molecule. So if we were to put these 2 on this carbon, you would just end up with the same molecule, just flipped 180. So there doesn't need to be a number for this one. So we're just going to call it eth, and then for the 2 carbons, and then anoic acid. Okay, and that bit is for the carboxylic acid part. Lastly, we've got esters. So esters are named by 2 parts. So we've got to focus on the fact that we have a propyl group here. Okay, this is a propyl group. And this here is an ethanoate group. So we call this propyl ethanoate. There doesn't need to be any numbers because there is only one way of bonding these ones. So that's a brief overview of how we name the different types of hydrocarbons.